So, in this tutorial, I want to show you how to use BraTS dataset. Before I show you how to access this dataset, I briefly introduce BraTS challenge. Then I give you more details about its data. Next, I explain how you can upload your results to BraTS server in order to validate your model. Finally, I tell you about evaluation metrics which are used in this challenge. But what is BraTS challenge? In order to evaluate the state-of-the-art methods for the segmentation of brain tumors in multimodal MRI scans and compare between different methods, since 2012, a challenge called Brain Tumor Image Segmentation Benchmark, or BraTS, has been organized. BraTS utilizes multi-institutional preoperative MRI scans and primarily focuses on the segmentation of brain tumors. Also, other tasks have been added to this challenge over the years, including the prediction of patient overall survival and the evaluation of the algorithmic uncertainty in tumor segmentations. In this task of BraTS challenge, we have to identify different glioma subregions. In other words, we have to assign label to each voxel of an input image, which shows different subregions of tumor. The subregions considered for evaluation are enhancing tumor, which is marked in light blue, tumor core, which is orange area, and whole tumor, which is the yellow part. So, you have to design a machine learning model which identifies these subregions. Once we produce segmentation labels, we can use these labels in combination with the provided MRI data to extract imaging or radiomic features and analyze them through machine learning algorithms to predict patient overall survival. And in uncertainty task, in addition to segmentation results, we should generate 3 uncertainty maps associated with the resulting labels at every voxel. For further information, visit this link. In order to download datasets provided by BraTS, you have to create an account in this website and wait for its approval. So first, you should sign up. Fill in the all requested details and press submit. After that, they send you a confirmation email within 3 or 4 days. Once your account is approved, log in and choose any BraTS dataset that you want. For example, here I choose BraTS 2019 and click on Data Request. Fill in the requested details and press Submit Job. After a few minutes, it gives you a zip file which contains 2 links for downloading training and validation data. There are 3 files in the training data: HGG, which contains high-grade glioma data, LGG for low-grade glioma, and a CSV file for survival data. As you can see, for each sample in the training set, 4 MRI modalities and ground truth segmentation labels are available. And for each patient in the training set, survival information, including age, resection status, and survival time, are provided. This challenge provides a multi-parametric dataset of MRI which contains T1, T1CE, T2, and filler images. The main reason is that MRI modalities provide complementary information. For example, T2 and filler are suitable to detect the tumor with pretumoral edema, while T1 and T1CE are suitable to detect the tumor core without pretumoral edema. All images were acquired with different clinical protocols and various scanners from 19 institutions. For each image, there are 4 labels: 0 for background, 1 for non-enhancing tumor core, 2 for pretumoral edema, and 4 for enhancing tumor. In the next video, I'll show you how to load and manipulate this data. As you saw earlier, survival data contains age, survival days, and resection status. Resection status contains GTR, STR, or NA. GTR means gross total resection, which means the removal of all tumors. STR means the resection where a part of tumor is left, and NA means not defined. In validation set, no segmentation map or survival time is provided. So in order to validate your model, you should upload your predictions to BraTS server. It is very simple. You only need to log in and click on different validation tasks. For example, for segmentation task, you only need to upload segmentation maps. Then click on Submit Job and wait for some minutes. After some minutes, it gives you the final results. Participants in BraTS challenge and people who use this dataset should report their results based on 2 different metrics. One of them is dice coefficient. Dice coefficient is used for evaluation of methods in segmentation and uncertainty tasks. For survival time prediction, accuracy is used. Predictions of participants in the challenge are assessed based on the number of correctly classified patients into 3 different groups: long survivors, short survivors, and mid survivors. But for post-challenge meta-analysis, both the mean and median square error of survival time predictions are compared. Well, this is the end of this video. If you found this video useful, please press like and share it with your friends. Thank you.